If an object is not accelerating, so a equals 0, the only equation that we're going to use is going to be v equals delta x over t, because this velocity is constant. So that means the change in displacement is going to be the same for every unit time. All right, so anytime we're not accelerating, so we're not speeding up, we're not slowing down, this is the one equation you're going to use. If an object starts from rest, it's being dropped, it just begins to move, then what we know for one of our variables is that v initial is going to be 0 meters per second. If an object comes to a stop, we're trying to find the max height of an object thrown upward, then what we're going to know is that v final equals 0 meters per second, or you can say because of that max height, v at the top of its motion is 0 meters per second. If an object is falling, it's tossed, dropped. So anytime it's going through the air and there's nothing, no forces working on it, you're not pushing it, you're not pulling on it, then what we know is that the acceleration is equal to the acceleration due to gravity. And for our class, we're going to be using negative, we're going to use 10 meters per second squared, okay? But we're going to assign it in the downward direction. So the acceleration is just 10 meters per second squared. We're going to make it downward. Okay, so the biggest thing that we want to get in the habit of is identifying the equations or the variables that we know. So we have 5 variables. We have delta x, v final, time, acceleration, and v initial. So these are our 5 variables. We're going to have 3 givens, we're going to have 1 unknown, and then it's going to turn out that one of these variables are not needed to solve. So the 3 and the 1 unknown, these are the 4 variables we need in our equation. And then if we don't have this, the question is, well, what equation would we use? So what you're going to do is you look at your list and you're like, okay, well, which one of these do not have delta x in them? Now this particular delta x, this is where acceleration equals 0. So we are talking about only our accelerated motion problems. Okay, so we would not use that one regardless. So this is 0 acceleration. So you might want to, when you get your test, put a equals 0 meters per second squared for this one, because then we're like, you know what, like this is if I'm not speeding up or slowing down. Delta x, these are the 2 equations where we don't need delta x to solve. So that's going to be a equals the change in velocity over time. Change in velocity, remember, is just v final minus v initial over time. And this equation is actually the same thing. If we multiply by t and we add v initial to both sides, then it turns out that v final equals v initial plus acceleration times time. These are the same equation. For the next one, if we have our 3 givens and unknown and v final is not one of them, we take a look and it looks like it's going to be the delta x equation. So delta x equals v initial t plus 1/2 at squared. If time is not referenced, we're going to use this guy. V final squared equals v initial squared plus 2a delta x. And then if we don't know the acceleration, but we know we are accelerating, then delta x equals v final plus v initial over 2, so the average velocity times time.